We have 30 participants, so we'll start the webinar right now. So hi everyone, good evening, and thank you so much for joining with us on this lovely evening. And before introducing our speaker, so let me introduce what this session is. So this session is organized by the IEEE Student Branch at Trobe University, and I'm the chairman. I'm Lakshita Gunasekara. And we at IEEE Student Branch, so IEEE means Institute of Electrical and Electronic Engineers. Even though it says engineers, now it has spans across all the STEM domain. So you all can join with us at IEEE Student Branch at La Trobe as La Trobe students or other stakeholders, and we do organize lots of STEM related science, engineering, technology, and management related sessions and events throughout the year. And you all can follow us on our social media platforms. We have a LinkedIn page and a Facebook page and a YouTube channel. So now let's move on with the webinar. And today the webinar will be on the Deceptive Data Storyteller, so Pinocchio. So you all know Pinocchio and heard about the story. So I guess you get an understanding of what this session is going to be about. And we have our guest speaker, Mr. Kanishka Randunu. So Kanishka is a business intelligence and data visualization specialist with over 4 years of experience in telecommunication, retail, IT consultancy, and aviation domains. He is specialized in transforming business data into strategic insights for informed decision making. And he is currently employed at TATA Consultancy Services, and he's consulting to Scoot Airlines Business Intelligence Division on data analytics. And before that, he was a senior engineer, data engineering and analytics at Cisco Labs Sri Lanka, consulting on Cisco Canada on data visualization. And he was a data visualization specialist at John Keel's Holdings and a business intelligence analyst at Dialog Axiata PLC, which is the largest telecommunication provider in Sri Lanka. He has a master's of business analytics at University of Colombo and a bachelor's of science in electrical and electronics engineering from University of Peradeniya. And he was recently recognized as a top data visualization voice by LinkedIn in for the year 2023. So Kanishka, the stage is yours.
Okay, hope you all can hear me and see me. Okay. Okay, thank you for joining this webinar. I know Mondays are always a bit hectic and a bit busy, and thank you for making time for joining this schedule. So today it's gonna be about some misleading data visualization types. This is, I think, purely based on my industrial experience. I'll go through what are the better data visualization practices to follow while you are on data visualization. Let me share my screen. Okay. Okay. Can you see my screen?
Yeah, we can.
And the left side, is it like meeting something? Oh, you can see the full presentation.
I think we can see the full presentation. Yeah.
Okay. Okay. Good. Okay. Yeah. Lakshita, can I go offline in the video? Is it fine?
Sure. Yeah.
Okay. Okay. That's fine. Okay. Okay. Yeah. So I'm Kanishka. I have seen many familiar faces also. And good evening to everyone. I think in Sri Lanka it's almost good afternoon. So I'm Kanishka, and what I'm doing is like data visualization and analytics consultancy. Currently, I'm working at TATA Consultancy Services, Singapore. So to summarize what I do, I am a data storyteller, and my job is to connect dots with data. So what I do is like I find patterns in data. I help businesses to make informed decisions that would be beneficial for their businesses. So that's currently what I am doing. And today, yeah, we'll start with our presentation, Pinocchio, the Deceptive Data Storyteller. So what you should know when you are planning a data storytelling and what you shouldn't do when doing a data storytelling. So goes as this story. Once upon a time, there lived this in the land far away. There lived Pinocchio and his father, and they were having a conversation. That's how this presentation starts. So Pinocchio's father is telling to Pinocchio, my dear Pinocchio, remember to be truthful and use good manners when you work with other people, and always try to be honest. And don't use your tricky skills to mislead other people. So it's like when we are in visualization, sometimes we try to improve our visualizations to improve others. So sometimes we will do things that are not best practices in visualization. So I just want to go through some of these visualization concepts so you can avoid them in your maybe in your journey in the data domain. So from Pinocchio's father's advice, you also can get many things out of that small talk when you are presenting your data, maybe to upper management, if you are in the research domain, maybe to your supervisor, if you are in academics, while presenting your findings. So when you present your data, this small talk can be applied. So data storytelling. I feel like data storytelling is one of like a key skill that you should develop when doing when you are in the analytics domain. Uh, because once you have done with all the technical parts, technical analysis, maybe you can do a machine learning thing, Python analysis, exploratory analysis. After you have done all your technical parts, then there comes a part where you should present your findings to either your supervisor or the manager or other stakeholders. So maybe you can be a very top person in technical part, but if you cannot convey that story to your management, then I think the effort you put into that technical part is not gonna get, the audience is not gonna get that message. So data storytelling is one of the main key things you should develop if you are in the data domain. So for data storytelling, this is what I think, like how you should do a data storytelling, how you should plan a data storytelling. This is my idea, and upon my experience, these are like the main 6 points I can summarize. First, you have to understand your audience. So audience can be technical, non-technical. There can be people who have switched their career path. So they may not be familiarized with some sort of technical terms. Some may not prefer very technical presentations. And you should understand whether uh, your audience expects you to go to like very technical details. So this is like understanding your audience is like the topmost priority. Once you understand your audience, your data story will be fully depend on your audience, how you understood your audience. So the next one would be the context. So in every story there's a context. So like if you are using the word star, so if you are in doing some presentation, let's say related to astronomy, then a star means like a star that's shining in the sky. But if you are presenting it to some people in the film industry, the star, the word will mean some other thing. So depending on your context, the way you handle your audience should be different. The terms you use, the techniques you use to present your ideas and findings, all those things would be should be different. And after you like get an idea, okay, this is my audience, and this is going to be my context, and this is going to be my background for this presentation or the data story. Then comes the technical part, where you analyze and summarize your data. So this is fully like you dig into data, you get all the data, you summarize data, you manipulate, transform data, and everything technical goes to this third point. Once you like analyze data, you can see certain patterns. Maybe you can see, okay, this week sales has gone down, interest rates are going up, there's a upward trend. Or either you can identify different customer clusters, categories, segmentations. So this third point is to understand all those insights that you think would be important to deliver your data story, and it should focus on your audience and your context also. So what I'm going to focus within this presentation and the webinar is to use relevant charts and visuals. The title will go as be truthful in data visualization. Otherwise, you can mislead your audience, and that would be like sometimes it would be financial, it would cause financial losses also. So if you are working in a very large company, the transaction amounts will be millions or billions. So if you deliver the wrong message, then I think it can affect a lot within a industry. Yeah. So before the last one, you have to maintain the story flow. Once you are telling the story, your story should be connected. So if you cannot start with something else and end with something else. Your start should be focused on your ending, and your story should have a flow, which will be connected to everything you are telling. So that's how a story goes. And the final thing is like how you end your story. So ending your story, like your ending should be pretty clear. This is what I found, this is my summary, this is the problem, this is the answer, and like kind of all those things you can put it at the end of the story. So those will be in the industry, mainly it would be managerial decisions, top insights, then next steps to the project kind of things. All those will be the end of your story, and you have to do it properly. So in a data storytelling, I would like summarize these 6 steps, which are very crucial. When you are delivering a data story, you have to understand the audience, focus on the context, and summarize your data. And you should be truthful while developing visualizations or making a report, and you have to maintain the story flow, and finally you have to end your story properly. So I think keep in mind these 6 points. That would be very helpful when you are planning a data story, maybe when you are in this industry, maybe when you are presenting some academic research findings. So these points would be very useful. Okay, moving on. Okay. Yeah. Data storytelling. Um, so every story has 5 main phases. I would say it's more like so data story. Although there's the word data, you can think it as a story that maybe your mother, your grandparents, your parents told you. So it's same like it's same thing with the data story. What we have to do is like attach all the findings, your methodologies, your key takeaways into that story. So it would be a data story. So these are the 5 main phases of a data storytelling: the beginning, the build up, the problem, the resolution, and the ending. Beginning is like in the beginning of your data story, you can introduce your problem. You can like uh, describe the context, what you are going to do, those things. Introduction, mainly the introduction part goes here. And after the beginning, the build up comes. And in the build up part, what you have to do is like give the audience an idea about what is happening and how did you identify the problem. So let's say somehow you identified, okay, there's a sales drop down, like uh, last month the sales has gone down. So that would be what's happening. And then you can give an idea on how did you identify problems. So maybe you have gone through your financial reports, maybe um, you observed negative value in your Excel files or something. That's how you identify the problem. That part goes with the build up phase. So that's how you build up your story. And on the climax, like climax is like where you explain your problem. um, so there you can describe the problem, and you can discuss about the impact. So you can give an idea, our sales has been hit and we have an impact of 1.5 million loss, kind of. You can include values, like if it is a measurable thing, you can include values and tell the impact. And the resolution part, in the resolution part, what you can do is like how did you overcome the problem and what steps did you follow. So it's more towards the methodology. How did you overcome the problem? What steps did you follow to analyze that problem? What data you gathered, what insights you gathered, those things, the resolution phase. Before the ending, you should give a clear idea to the audience. Okay, these were the things that I did for this analysis, and these steps I have taken. These maybe you can include some technical values also, and you can make the resolution phase. And at the ending, you can like give the most important details. What will be the next steps? Are we going to um, increase marketing? So if your sales have been impacted, you can like increase marketing, or maybe you can um, contact more sellers and check whether where's the issue. And uh, from your analysis, what is the learning outcome and summary of the most important insights discussed within your presentation. That's how you end your story properly. So these are the 5 main phases of every data storytelling, not a data storytelling, but a storytelling. These are the main 5 phases: the beginning, build up, the problem, resolution, and the ending. So when I'm doing a presentation, what I'm trying to do is like I normally do not include much text within presentations. Only the relevant parts and things that I want to emphasize or highlight. Those are the things that I am including in my data storytelling. Because many people don't like to go through so many texts, and they cannot like remember so many things at once. So it's very important to summarize only the necessary things, and all those insights should focus on your final storyline. So the flow of the story, everything is very important. And how you build up the story depend on, like I previously said, your understanding about the audience and the context. Okay. So we are back to Pinocchio's story. And so you have heard that Pinocchio's story. Pinocchio was given a mission this time. Okay, Pinocchio was given a mission. Yeah. So the mission is like there's a like every uh fairy tale, there's a princess and there's Pinocchio and there's a very fiery dragon. Your task would be something like rescuing the princess, like that's how magical stories go. So Pinocchio has to rescue this princess from the fiery dragon, and fiery dragon gave Pinocchio with 10 data visualization tasks. So fiery dragon told that if you want to get the princess, you have to um, complete all these 10 visualization tasks, so then you can go to the princess, get the princess. That's how this story goes. That's how I planned the story to go. So we'll go through like what these 10 data visualization tasks the dragon gave, and we'll see how Pinocchio did on those tasks. So this will be the map. Pinocchio is in one corner and the princess is in other corner. Um, and there are 10 tasks, and Pinocchio will have to complete one by one, and all these tasks will be related to data visualization. We'll see how this goes on. So I think you can help me out. I think you can be a bit interactive with me while going through this journey, and we all can help Pinocchio to complete all these tasks. Okay, so after like this happens in real lifetime also. After seeing the princess, Pinocchio forgot his father's advice. So you may remember that in the beginning I said that Pinocchio's father gave some advices to Pinocchio, but Pinocchio forgot all the advices, and he became fixated on the princess. So all he thought was only about the princess, and that made Pinocchio to cheat. That's how Pinocchio is. Pinocchio is always cheating, always telling lies. So Pinocchio forgot his father's advices, and what he could think was only about the princess, and he cheated. That's what happened in this story. So Dragon was very angry. Dragon said, okay, Pinocchio, I'm very angry with you. I will give you one more chance to correct all the mistakes. Um, yeah, Dragon is very angry, and Dragon will give only one chance to Pinocchio to correct his all mistakes, because Dragon knew that Pinocchio has cheated, and he wants Pinocchio to correct all those mistakes. So can you help Pinocchio to rescue the princess? So that's your task. I'll guide you throughout the journey, and what you have to do is like help the Pinocchio to rescue the princess. Yeah. Task one is, so I didn't like very put very detailed explanation on the task. It's just you have to plot gun dates in Florida after the enactment of stand your ground law. So there was this law enforced in Florida called stand your ground law. The purpose of this law was to check whether they can reduce the gun deaths after this law. So Pinocchio has to do as the first task, Pinocchio had to do a data visualization to plot these gun deaths in Florida after this law. So this is what Pinocchio plotted. And I want someone of you to speak up and tell what what like mischievous thing Pinocchio has done here, what wrong, whether this chart is correct or not. And can we help Pinocchio? How can we help Pinocchio? If the chart is incorrect, how can we help Pinocchio to build a better graph? So I would like anyone to speak up and help me, me and Pinocchio as well, to identify what is wrong with this chart.
Kanishka, Vidura.
Yeah.
I'll give it a go.
Yeah, sure. Yeah.
So I see the y-axis is labeled from 0 to 800, from top to bottom.
Yeah. So, yeah.
Yeah, I think it has to be flipped.
Okay. So why has like Pinocchio done this?
In order to cheat.
Yeah. So we see that after in 2005, we see that Florida enacted its stand your ground law, and according to this visual, the gun deaths has gone down. Like if you don't see the y-axis correctly, you can see the trend has gone down. So somehow Pinocchio wanted to show that after this law was enacted, the gun deaths have been affected, and that has actually gone down. So it's a good thing. But when we see, like, when we analyze this chart, what, like Vidru said, what we see is like the y-axis is inverted. So it's like the chart has misled the audience to make sure that they think that the gun death trend has gone down. So I think this is a use case where improper use of axis has been used. So in your data visualizations, you should not use improper ways like manipulate X or Y axis to tell a different story. So if you manipulate your data visualization, it will tell a very different story than the original story. So in this case, actually what has happened is, like, after the law was enacted, the gun deaths have gone up from around 580 to 800. It has gone up, but this chart shows it as it has gone down. So it's a case of improper use of axis, and like it's not good to manipulate your X or Y axis while you are doing a data visualization. And I think this chart can be corrected like this. This is the original chart, the corrected chart actually. So in the actual data story, you can see gun deaths have gone up. Although the law has been enacted in 2005, gun deaths have been gone up. So this is like a, I think, popular visualization, not a one I created. It's a popular visualization you can find online, but um, the visualization has been done in a way to mislead the audience to think that gun deaths have been going down after that law. So that is, yeah, that's the first task, and you saw that Pinocchio has done it wrongly, and this is how we can help Pinocchio to correct all these charts. And I think I have 9 more tasks, or 9 more others can help me with all these tasks. This is not going to be much of theory, so I think it won't be boring. Even I am not much of a theory person, so I wanted to make it sure it's not very loaded with theory. So that's the first thing. You shouldn't manipulate your X or Y axis, and it would tell a different story. So yeah. Okay. So one task completed, 9 more to go, 9 more tasks, and I think Pinocchio would be lucky to get to the princess, rescue the princess with your help. Okay. So yeah, the second task is to plot ice cream sales versus crime rate. So there's a very the task is a very descriptive one, but I just want to make it simple. So you just have to plot ice cream sales versus crime rates. Um, so this is what Pinocchio came up with. Um, and depending on the data, I think it's kind of not a fault of Pinocchio. Maybe if he did the analysis, maybe it's his fault. But if the dragon gave the data, then it's not like 100% Pinocchio's fault. But this is the chart that Pinocchio has drawn. There may be like more than one mistakes in the visualizations, but I am trying to emphasize only one principle out of every visualization. So anything you observe that you think is a mistake, you can tell. So would be helpful to Pinocchio. Yeah. Hi, Dennis.
Yeah, hi. My question, Kazuka. So actually, in this chart, I think it's trying to misleading people by trying to show the relationship of two factors where it is completely like randomly coincident by each other. So
Yeah.
actually, so it's two different factors, but with similar pattern. But they're trying to set a relationship where there isn't such any.
Yeah. Great. Yeah. That's like the perfect answer, I think. It's like when you're comparing something, like when you're building a relationship, maybe uh, you can compare apples to apples, like that's the correct way. But if you are going to compare something in industry, you will find so many data sources, like it will have HR data, financial data, marketing, sales, and like every kind of data you can think there will be data. But when you're analyzing something, you should be careful what relationships those attributes can have. So you cannot compare something like it's out of your knowledge, like your domain knowledge. So you know that ice cream sales are not like a very major factor affecting violent crimes, that you know, because of your domain knowledge, like the normal knowledge you have, like in the business industry also, you should have that understanding, the domain knowledge to compare attributes. You cannot compare ice cream sales with violent crimes. There can be a relationship, maybe it's a very positive relationship, maybe a negative relationship. They can be like have a very good Pearson's correlation. But there's always a question, are these two variables, maybe two or three variables, are related to each other? So this is one um, data visualization practice. If you are going to compare non-related attributes, so actually this is called confusing correlations. So when you are looking into relationships between variables or attributes, you should not use confusing correlations. You cannot, although this chart says ice cream sales are like very correlated to violent crimes, it's like if I sell ice cream, there might be a death. So the story that this chart says is something like that, but it's not related. Although in a numerical or a graphical way, it shows the correlation. We cannot compare non-related correlations. This is one of the main things that you should memorize while doing a data analysis project. Okay, thank you, Dennis. Yeah. I saw someone. Hi, Lasita. Yeah.
Hi, Kanishka.
Hi.
So I have a question. Is there any industry recognized standard to recognize these correlated correlations? The causation is actually a thing. So in this case, this correlation we can ignore, like, okay, ice cream sales are far away from, it's a far cry from violent crimes. So is there any particular technique or method that we can use to identify correlations, which causation leads to causation?
So normally what we are doing is like you can like statistically you can there are ways to identify relationships between attributes, but that's the problem I discuss here. Although there can be a relationship, like numerically it can be maybe the correlation can be -1 to +1. For this special case confusing correlations, I think the best way is to have the domain knowledge. So the domain knowledge, what I do in the industry is like when I start doing data analysis project, sometimes. So okay, from my recent experience, I recently joined Scoot Airlines. So previously I haven't worked with airlines data. Aviation data is very different than retail or telecommunications data. So the domain is that. So currently what I am doing is I am in this aviation domain. Previously I was in telecommunications and retail. So depending on your domain to domain, all the attributes, the way you are defining them, calculations and everything like changes. Maybe the same attribute, the definitions will be different. So if you take in telecommunication, churn, like customer churn means if a customer leaves a company, it's called a churn. In telecommunications, churn is defined in one way, and in retail, a churn is defined in another way. So in a telecommunications company, if you disconnect your SIM card, the customer has gone. But in retail, like if you are coming to some supermarket and there's like no cancellation to be done on a supermarket. So the how a churn customer is identified is different. So to avoid these confusing correlations, what I suggest is to take domain some expertise knowledge. So what I do is like, okay, recently I started a project. I didn't have the domain knowledge on aviation domain when I was starting with the school. What I did was like I arranged a meeting with the sales team. So they are the people who have been working with sales data for like more than 5-6 years. So they have the fully understanding on how these are related. When a customer cancels a booking, what happens, what are the factors affecting booking cancellation kind of things. So I think the best way to avoid this is to get expertise opinion. If you don't have the domain knowledge, you can always ask your project stakeholders how these attributes are correlated, whether this is affecting this. So normally this happens in the business requirement gathering process. You can ask what are the factors affecting, let's say, sales in airline aviation industry. What are the factors affecting, how these are correlated? So that's what I think.
All right. Thanks.
Like,
that means like, yeah, that means we can just simply, if there's any correlation, we could just simply present it to them, then ask the expert opinion in that case if we don't know about the correlation.
Yeah.
All right. Thank you. Thanks, Kanishka.
Okay. Yeah. Okay. Thank you for the question. Okay.
You're welcome.
So we have successfully done 2 tasks, and Pinocchio is like getting closer and closer. Let's go to the third one. Third one is about the task 3 is all about plotting like type of food versus number of calories. So if you are a gym person, I'm not a gym person, but I had to plot this chart so I know type of food and the number of calories. So meats have this number of calories, this number of so maybe rice have this number of carbs kind of things, vegetables have this kind of Pinocchio has to plot these food type versus the number of calories. So here it's more like it's not a mistake. Like it's not a mischievous thing Pinocchio has done, but he could, I think, I'll tell, he can do it better. Something like he could have done this better. So anyone can tell, I won't say there's an error, but I think we can improve this. So anyone, any ideas on how we can improve this chart? Come on, guys and girls. It's very simple, like just a casual chat. I can help you with the build up. So if someone willing to talk up, let's go through it. Okay. Yeah. Radhika. Yeah. Okay.
Yeah, hi.
Hi.
I think the what my mind tells me is they have taken 100 gram for different food. I think it could have been done better with the serving proportion or serving size.
Okay. Okay.
Yeah.
So you're telling okay, I actually I didn't think of that because I was going to emphasize one other
Yeah. So
okay.
yeah,
Like
from my
is there
perspective,
some
yeah.
way
Yeah.
do you think other than the data, let's say I would help you. Visual wise, is there any way that we can improve this chart?
No, I'm thinking. Yeah.
Is it better if we use different colors, as in one color
Yeah.
shade instead of
Yeah.
multicolors?
Yeah. Colors definitely can be improved. Yeah. Tharindu, yeah.
Yeah, hi Kanishka. Yeah. I think you don't need the legend on that side because
Yeah.
it's too much information here now. So
Yes.
like it's already
Yeah.
there.
Yeah, that's correct. So yeah, thank you. That was good feedback. So I think this part, like this task, is very important. Like it's one of the best principles I have learned while doing data visualization. So I'll go through one by one. Like there's something called so this principle is called data to ink ratio. So there's a low data to ink ratio. It's like how much data can, like it simply I will say it's like how much ink you waste to show data. So if you can show so much data from a less amount of ink means like, let's say you are going to print this visualization and you are going to waste some ink. So if you can use less ink to show more data, then that would be like a very good visualization practice. In this case, we can see so many things that can be improved on data ink ratio that can be improved. So I'll just tell, I'm not sure whether the charts are very visible to you, but this is, I'll just go through one by one. First one is like the background. We don't need the background here. So to keep the visualization more focused and less cluttered, we can remove the background colors. Then you can see in the second chart, the background is white. Still, there are so many improvements that we can do. So as I don't exactly remember the name now, the legend can be removed because it's like we are repeating the same thing. On the bars also in the x-axis, we are saying, okay, this bar is for French fries. This is for potato chips and bacon, pizza and chili dog. And on the legend also, we are telling the same thing. So it's like a repetition and we are wasting ink for that repetition, which is not telling like specifically telling a different insight. So we can get rid of the legend in that case, and maybe the outer side border also. So then we comes to the third chart, and on the third chart we can see, okay, maybe you can, like, let's say you have to highlight bacon. Then you can get rid of all the other colors because they don't add a value to the visualization. It's just like visually appealing. To me, it's not visually appealing also. So including so much colors distracts us from the main purpose. So if our purpose is to highlight how much bacon has, how much calories bacon has compared to other food types, then the other colors distract us from the purpose. So we can get rid of all the other colors, only keeping bacon highlighted. Then we comes to the fourth chart, and from the fourth chart, what we can see is like okay, there are grid lines that, and there's a 3D some shadow effect also in the bars, and they do not like help to the data story. It's just some visual things that we can get rid of. So we can go let go the grid lines and the shadow lines also. Then we come up with this chart, and sometimes it's good to keep the y-axis if you want to, let's say your bar sizes are, if your bar sizes are very small, then you can keep the y-axis. But if you have less number of categories, then you can show your value on the bar itself. So that would be more easier than like referring to the y-axis, dragging your cursor to the bar and looking at the value, like assuming this value is around that range. If we can show our value directly on the bar, it can be very user-friendly, I would say. But if you have so many categories, then your bar sizes will be very small, and then you might not be able to show those values on the bar itself. So in that case, it's okay to have the y-axis. But in this case, we have less number of categories, and we can improve our data ink ratio using this, like removing and getting rid of those unnecessary clutter and unnecessary colors, background colors, and other bar colors, grid lines, shadows, yeah, everything. I think title, okay, one thing, title also in the first chart, it says calories per 100 gram for different foods, but we can also reduce, like limit the title just to focus on what exactly what we are planning to tell. So I think this is one of the main principles that I have learned in my journey. And this is the principle is from Edward Tufte. He's a very pioneered, I would say, in data visualization. He's like a very pioneered person. He has introduced some principles to data visualization, and this is one of his principles. We also always should try to have a higher data ink ratio. That means we should visualize more data from a lesser number of ink. Did you like get it, or should I like explain anything more? I think it's very important for you to remember this. Always do not try to repeat the data itself, and to make the visual more like visually pleasing, don't add too much color and like 3D graphics or shadows. These are not very helpful to convey our data story. Sometimes they may be beautiful if you like combine matching colors, that can be good. But most of the times when your number of categories, your data size, amount of data, complexity of data goes up, it's very good to follow a very minimalized theme while visualizing data. So it would focus on the very important details. Anything you need to know about that, or should I move forward?
I think I've been very clear about it.
Okay, thank you. Yeah. Okay, yeah, now we have done 3 tasks. Pinocchio is there and the princess is still far away. We have to complete, I think, 7 more tasks. And this one is about plotting the number of people who backed a presidential candidate. So in a presidential candidate, there will be presidential election, there will be let's say 3 or 4 candidates, and this chart tells about this chart should tell about how people are backing their candidates. So like we'll say we have 3 candidates, A, B, and C, and we have 100,000 people. So 20,000 people are backing A, 30,000 people are backing B, and 50,000 are backing C, like that kind of a scenario. So Pinocchio has to visualize that scenario, and this is what Pinocchio visualized, and what is wrong with this chart, and how we can help Pinocchio to correct this chart. So anyone?
Hi, Kanishka.
Hi, yeah.
Yeah, I'm just thinking for this chart, the pie chart should equal to 100%. And then we can probably remove some of, like, put it in the legend probably, or remove the back in the chart.
Okay, great. Yeah. Thank you. Yeah, that actually what I wanted to emphasize was the first thing that I said. This chart doesn't add up to 100%. That's the main issue. On the visually wise, as we previously like described in the data ink ratio, we have so many developments that we can do in this chart. But for this task, the task should be task 4 or something. What is wrong is, I think it's more on the data side. So data doesn't add up to 100%. This may happen because sometimes when there's an online survey going and you have to tick, okay, I'm going to support candidate A, candidate B, candidate C. Some people support more than one candidate. So when you get a percentage, that may not add up to 100%. That's one of the scenarios that could have happened. Maybe either when Pinocchio does his calculation, he has done the calculation wrong. That also can happen. What I wanted to emphasize here was incorrect data. So if you use incorrect data, your visualization would be very incorrect, and it would tell a very different story. So it's like 70% people are backing Palin or someone, and 60% are backing Romney, and 63% are backing Huckabee. But that might not tell the exact story, because some people have marked that they are backing 2 or 3 people. So when you're using, like, creating a data visualization, it's very crucial to validate your data when you get data from. So in nowadays, like most of the companies, like what I have observed is they have previously they were having on-premise data sources, data warehouses, and they are now majority have already migrated, but they are in the process of migrating them to cloud. So in cloud, you may have Azure, AWS, maybe GCP, Google Cloud. So many cloud options are there. And on premise, that would be some Oracle databases. So the data sources are very different, and sometimes sales data is on Oracle database. Sometimes the marketing data is on Azure. I have come across cases that some departments still use Excels to maintain their data. So they are like using Excels, updating them month on month. So it's very hard to get all those data at one place to do your data analysis. It's like, so if I would say around 70% of effort you have to put into data and validation, data gathering, identifying the definitions, kind of like in a project, around 70% your effort goes into that part. So that is the toughest part. And once you get data from many different sources, there can be very different logics applied to each attribute. So your calculations might be wrong. Sometimes you will have incomplete data. Sometimes your data might not be relevant, not updated. Yeah, those can happen, and these will lead to incorrect data. Once you get all those data into one place, you have to do some kind of a validation. Again, this, so in sales, you can like validate with manual reports or sales reports that were previously kept by the sales division or something. You can like do validations and identify whether the data is synced and tallied with exact logics and everything. So I think one of the best practices in a data visualization project, like data analysis project, is to use correct data and always to validate your data. Expertise, opinions, or like if you want to validate sales data, you can ask someone from sales department, okay, whether these values are correct. Can you give me a last month sales report so I can validate against that? Those things you can do in the industry. So I think validating your data is one of the main things you have to do in a data analytics project.
Kanishka, there's one thing I want to ask from you. So since like we had a pie chart over there, so what's your take on like using pie charts on visualization? Like let's say like, so here the data is correct and each of these candidates got like 33%, 30% and 36%. And when the percentages are like equal, not equal, like similar in kind, do you recommend using pie charts?
So it's like the normal thing in pie chart is like if you have less than 5 categories, okay to use pie charts. Like let's say you have 100 categories, then you cannot show all those 100 categories on a pie chart, and then you cannot show the labels like 100 categories. One can be 1%, the other can be 2%. So or if you are going to plot all those things in a pie chart, that would be like a mess. So the norm is, do not use pie charts if you have more than 5 categories. If you have more than 5 categories, you can just go for a bar chart. That's like the preferred chart if you have many categories. Pie charts are like not always preferred, but sometimes it will show like rather than a bar chart, it will show, okay, this much of proportion is occupied by this category. So sometimes it is useful, but unless your number of categories are more than lesser than 5, don't go for pie charts. That's like the norm, I think.
Okay, thank you.
Yeah, so this is about incorrect data. And yeah, we have completed 4 tasks and like 6 to go. Don't feel like bored, just help me with the journey. Yeah, so task 5, plot annual interest rate. So there's a whole story behind this, but you have to just plot the annual interest rates, whether what's going on with the, so interest rate would help you to understand some kind of inflation, or whether you are going to invest on something. This would be helpful. So plotting interest rates, this is how Pinocchio has done, and how can this be improved, or what wrong Pinocchio has done. Anyone?
Is it that the line chart should be used here?
Yeah, can be. Yeah, yes. Line charts. Yeah, using line charts is a good visualization practice, since the x-axis is dates. That can be done. Yeah, that's a good thing. Yeah, Mahesh.
Is it because the y-axis is the increase is a lot less? So you can say that he has misrepresented how much it has increased. It
Yeah.
hasn't increased that much.
Yeah, so the both answers are correct. I was just focusing on telling the second part of the story. Actually, if you are going to like plot, like if there are like 20, 15 years, it's better to actually go for a line chart. In this chart, what I wanted to emphasize was this is kind of like a truncated y-axis. So you can see this y-axis does not start from 0. He has the Pinocchio has started this y-axis from 3.14 and plotted this y-axis because if we see this chart, it feels like the interest rates have gone high, like within recent years from 2008 to 2012, the interest rates has gone like very high. But in the actual case, it's like this. So if you plot from 0, there's not much deviation in the interest rates. But Pinocchio has used his mischievous skills to show that interest rates have gone up from a large amount, while the actual story is something else. So this is like a truncated y-axis, and do not use these kind of manipulations, I would say like data visualization manipulations, to misguide your audience, and it's a better practice to avoid these things. Let's go to the next task. And we have almost come like halfway, and to the 6th task. Plot states. Okay, that went really fast. Okay, so the states versus their gains and losses, it's something I found. All these charts are actually found on internet. The charts people have done in like to mislead the audience, or either the charts have been done incorrectly on purpose or without knowing the purpose. So all these were found online. So this chart, what they tried was to plot the states and their gains and losses. Let's say whether some kind of a state, whether it's let's say sales, if they have done a profitable sale in that state, or a negative sales, like whether it's a gain or a loss in that state. So what is the wrong thing in this visual? I think the numbers are a bit blurry, but I hope you can identify the issue here.
Kanishka,
Yeah.
so I think maybe the color here, if we can choose sort of two colors which will have sort of middle color will be more similar to one of those colors, maybe like dark blue.
One thing is correct. The color thing is correct, but there's something to be added on that. Mahisha, yeah.
Maybe flip the colors around so that the more profitable ones are in green.
Yes. So the issue is with colors actually. this chart shows, okay, I'll keep it as it is. So if you can see the legend, it says the negative 32,000 something, and the negative colors are green, while the positive colors are red. Like, it's not the normal way that we use green and red. So normally in like, this is like very important in, like, when you are presenting some insight that you found on your analysis, always try to keep positive values. There's a different psychology on color using in data visualization. Normally blue is to, what I know is, like, blue is to make it more trustworthy. Red is to alert something. Red and orange, yellow, those thing colors, kind of like warning or negative values drops. That's for red. So positives always goes with green, sometimes blue. Depending on the color, there's a different psychological thing that we discuss in data visualization. It's very interesting. Maybe you can find many resources in online. But normally what we do is, like, in the industry, to show a profit, we use green colors, and to show a loss, we use red colors. And this is the example where those colors have been used in an incorrect way. So this is called unusual coloring. So one thing is, like, colors are also too bright. That's one thing. And the main thing is, like, colors are not matching with the data story you are telling. So if you go with this chart and present it to your manager, he will think like, okay, like, around only 4 states we are profiting and all other states we are losing, and he might, like, close the company and go home. So, like, that could happen. So coloring is very important in a visualization. So it's like, visualizations are colors actually. Then it's not you cannot use, but it's not good to use unusual coloring. Yeah. Thank you for the answers. So the correct chart would be something like this. We can, like, reduce the contrast of colors also to make it more pleasable to the eye, and we can flip the colors, positive to be greens and negatives to be red. Okay, yeah, 4 more tasks to go. Task 7. Okay. So this is, you have to plot television viewing category versus the number of viewers. So there are so many categories. If you like, it's like genres. Whether you are looking into news, whether you are looking in films, teledramas, documentaries, kind of. There are so many categories that on a television we can view, and this chart is for that category, the number of viewers. And this is what Pinocchio has plotted. I think the same question, I think, as I remember, Lakshita asked whether it is good to use pie charts. And I think the answer was there. It's not good to use pie charts in this case. So you have so many categories. You can see that sometimes there's a small red bar that you cannot even like see, and you cannot see what value it has. So it's like the red, I think it's video cassette recorder, something, some kind of a thing. You cannot know how much, like, as a percentage, how much people are viewing that category. So this is, I'll just go through this is a wrong chart selection. Rather than this chart, I think the bar chart would be the best option to go for this one. So selecting charts is like one of, like, another important thing, depending on your data. So when you're selecting a chart, you have to see whether the data is categorical or numerical. So normally in a bar chart, what we do is, like, we take one categorical variable or one numerical variable, and we see how these categories have, let's say, number of viewers. So this category has this number of viewers. But in a scatter plot, if you are going for a scatter plot, the attribute types are different. Both the axes should be numerical. So it's a scatter plot. So depending on whether it's a line chart, bar chart, there are charts called ribbon charts, waterfall charts, butterfly charts. There are so many types of charts, and like we know commonly used charts like pie charts, multiple bar charts, stack bar charts. There are so many variations also. So chart selection depends on your experience. One is your experience, and one thing is like how much data you have. So in this case, there are so many categories. You cannot plot it in, it's not good to plot it in a pie chart. It's good to plot this in a bar chart. So the chart selection depends on the amount of data you have, type of data, your experience, and depending on the tool that you are using also. So like in industry, mainly we are using Power BI, Tableau, and some companies use ClickSense. So depending on the tool also, there are limitations that some charts cannot be drawn on some platforms. Like in Tableau, it's a bit hard to plot pie charts. In Power BI, it's easy to plot pie charts. So depending on the tool or the platform you're using, the chart selection would be different also. So that would be one other point you should definitely remember while delivering your data store. Okay, last three, task 8. Okay, this is like gasoline price change in Canada from 2019 to 2021. So the price change, so everything is like world is like in a financial something, and prices are going up. I think the inflation is going up, so gasoline prices we can expect to go up. So to make sure is the trend, whether the trend is going upwards, downwards, whether there's a relationship kind of things, we can plot a chart to identify the trend. So this is one task, something like that. And this is the Pinocchio's output. What you can like get from this chart, like what's wrong here?
I think the x-axis is not continuous, and the interval is not evenly spaced.
Sorry, yeah. Okay, so I messed up with something, just give me. Okay. Okay. Actually, yeah, what's happening is okay, just okay. So we were asked to plot data from 2019 to 2021, and like 2019 May to November 2021. But in this chart, there's data for only from 2019 May to February 2020. So like after February 2020, the story is not there. The story is not complete. So Pinocchio has tried to show that gasoline price has gone down within this time frame. This is called cherry picking or omitting data. So like it's like cherry picking. We have picked up something from somewhere, but it's not like the whole part we have picked up. Else it is called omitting data. We have like dropped data from 2020 February to November 2021. We have dropped those data. So that's called cherry picking and omitting data. And this chart, the correct chart should be like that actually. So if you like, when your chart is not complete, if you have like dropped or omit your data, or if you have like select a very specific part of data, like very specific date range, maybe date range, maybe sales division kind of. If you pick up, like it's called cherry picking, if you pick up some specific parts only, the story will be fully different. So you can see that gasoline prices have actually gone up, while Pinocchio has shown gasoline prices has gone down. So this is called cherry picking, and do not omit your data, and be very careful in filtering out your data. So sometimes we have to filter out data, limit your data. This is totally depending on yeah, Dennis, yes.
Sorry to interrupt.
Yeah.
Yeah, for this this part, I just wonder, have you ever been in the situation where you have to be asked to deliver some cherry picking tips like this in order to show just half of the picture, based on the request from the high manager to just show the, let's say, one positive side of the project, something like that, to the higher manager, so that the team gets like the better reward, something like that, and try to hide some other part.
Okay. Yeah, you're asking whether I have come across that kind of a situation?
Yeah, because like, for example, when we are giving the report to higher manager, sometimes we'll be in the situation where we have to show the good things first to give the good impression, or to give like positivity into the team, something like that.
Yeah. So yeah, sometimes, like, yeah, we have to, when we are in the industry, sometimes there might be requests like that. It's like you should be very careful in handling that, I would say. Okay, I think it's like, yeah, sometimes your managers can ask, okay, sales has gone down, until we find the exact solutions, and like this, we only have like 5-6 hours to make the presentation to the top management, and we don't have much time to go through every detail what has happened and everything. So let's, like, for this meeting, let's just show only this part. That might can happen, and that have happened. That's how, like, the business has gone, like industry goes on. Sometimes you have to be very careful in handling those situations. It's like how you handle the situation, actually. Okay. Yeah, sometimes it's like, actually sometimes it's good to, there may be like both goods and bads. Sometimes if you are not sure why this drop has gone down, and if you have like a presentation within like say one hour, and your purpose is not to show that drop, but if it is another case, then sometimes it might be okay to for that presentation only. But I wouldn't suggest that if you are focusing on, let's say, if you are focusing fully on sales, and if there's a drop, and not showing, that is not good. But if you are focusing on some other thing, and this chart is like some kind of a supportive chart, which the main focus is not sales today, then for that, that's a fully decision making point. For that special instance, you can just focus on your main part of the story. But it's always good to not manipulate the charts. Then the responsibility, I think, comes up to you at some point. If the responsibility should comes up to you, and it's not good to manipulate your charts. That's what I would say.
Yeah.
Okay. Even I got confused. Okay, so up to the last 2 tasks, I hope this wasn't boring. I tried my very best to keep it not boring. So 9 tasks. You have to plot the number of tourists from 6 neighbor countries to 4 popular destinations. Like say, we have 6 countries, let's say New Zealand, Singapore, China, like 6 countries, and we have 4 popular destinations: Melbourne, Sydney, Perth. We have like 4 popular destinations. So we are checking, okay, from Singapore, how much people visited Perth this year? From let's say New Zealand, how many people visited Melbourne this year? That kind of a chart Pinocchio was given to plot, and this is the chart Pinocchio has plotted. Actually, this have like so many things that can be improved, but I'll just focus on one thing. What do you think about this chart? What can be improved? What are the things that are not there? What can we add? Anything would be helpful to Pinocchio. Yeah, Iman. Yeah. Yeah, you can go.
So I think stack bar graph would be much useful, and
yeah,
obviously there is no x-axis or y-axis shown in this one as well, and
yeah.
maybe a slicer could do as well to select the thing like what
Yeah.
what countries, like when we highlight it can be shown like that as well.
Yeah, that's like a fully complete answer, and like we can, yes, we can use a stack bar chart. That would be one good option. Here what I wanted to emphasize was unlabeled charts. So don't keep your charts unlabeled. This chart can be improved in many ways, like data ink ratio. We can get rid of those shadows, background, grid lines, and we can use a stack bar chart. We can work on colors. There are so many improvements. I just wanted to say sorry, unlabeled charts doesn't tell you a story. So this chart is just like few bars, and it doesn't have anything else, and you cannot like build up insight from this chart. So don't keep your charts unlabeled. Always label your charts, label x-axis. Sometimes you can avoid labeling x or y axis. If your title says, okay, this is this chart sales versus year, then sometimes you can just ignore labeling x-axis, because when you're creating a dashboard, let's say dashboard is like a collection of visualizations. You have to show so many visuals within one view, and sometimes we get very lesser space. Like there are line charts. If you are going to show data for 5 to 10 years, then the line charts would be very wider. Then your space is very limited. Sometimes if your title says sales versus year or annual sales, then you can get rid of labeling x or y axis. Labeling means like x axis is year. That's called the label. Sometimes you can get rid of that. It's fine, but don't keep charts unlabeled. If someone cannot understand the story behind that chart, then it's kind of like unlabeled chart. So this can be like more improved. Like this is not the optimum way to improve this chart, but you can label this chart like A, B, C, D, E, F with neighboring countries. X, Y, Z, W is the destinations, and y-axis shows the number of tourists. This is how you can like, then this will give a far better idea than the previous chart. That's what I wanted to tell. Okay, to the last task of, so you can see like Pinocchio is very near to the princess, and we only have one more task. And if you like complete this task, I think that would be the last thing that we can do for Pinocchio. So the final task is to plot the number of crimes versus the state. So all these charts are taken from the internet. So sometimes they have crimes. I couldn't help. All these charts were from internet. So this one, plot the number of crimes versus the state. This is our final chart for today, and final bad thing that Pinocchio has done, and the final help that we can do to Pinocchio. So let's give him a support. Who wants to be the final helper? Anyone? Lakshita? Oh, you can tell.
All the bubbles are like similar in size, is it? And there are like hundreds of bubbles.
Yeah, like yeah, we can work on the visual aspects. We can work on like colors. There are so many colors and everything. We can improve the data ink ratio. But one thing I wanted to mention to you was as the final like concept or the better visualization practice. Don't fill your audience with too much information. So if you see this chart, this is too much information, and like we cannot process all those information at a glance. So the x-axis shows property crime for, let's say, 100,000 people. Y-axis says violent crimes per 100,000 people, and the bubble size says it's proportional to individuals below poverty level. So they are trying to tell a story with the poverty level increases, poverty level affects the crime rates, violent rates, those kind of a story. But the way they have like conveyed it is like there are so many bubbles, so many information within one chart. We have to at the same time we have to think of three attributes: property crimes, violent crimes, and individuals below poverty level. That's the bubble size. So in this case, it's not very efficient to use this kind of a chart to tell the exact story. It's like you are trying to put all your stuffs within one basket. So I would suggest this can be improved. You can just maybe divide this into 2 or 3 charts, rather than like trying to add all the information within this chart. I think that would be important. So don't use overloaded information. Always try to keep it simple. Everything according to a theme, focused on your final story that you want to deliver, and thinking about your audience. Like follow these 10 principles while you're creating a data visualization or a data storytelling, or you are doing a data analysis. I think these 10 principles will help you to be good in data storytelling, and I think it would help you in the industry a very lot. So that's how the Pinocchio's story ends. Pinocchio was able to rescue the princess with your support. Thanks to your help, Pinocchio was able to rescue the princess, and they lived happily ever after. That's how a magical story ends. So I'll summarize the bad visualization practices that we have discussed throughout those 10 tasks. So it would be easier for you to memorize it. First thing is like, don't use improper, like don't manipulate axes, like improper use of axis, don't do that. Next thing is like confusing correlations. Don't use confusing correlations. Always try to get industry expertise ideas, ideas from industry expertise, to get an idea on whether your attributes are correlated and how they are correlated. Low data to ink ratio, always try to maintain a high data to ink ratio. Do not use low data to ink ratio. Always try to get rid of unnecessary things in your visualization, like 3D chart, 3D effects, shadows, unnecessary coloring, very lengthy titles. Get rid of that and just always try to focus on the exact insights that you want to emphasize. Don't use incorrect data, and don't truncate y-axis to manipulate your story. Use matching colors. There are like color palette generators like Adobe palette. You can search on like Adobe color palette generator. So if you select one color, then you can select like other colors matching to that color. So in a visualizer, normally in a dashboard project, like always try to be in the range of 5 to 6 colors. 5 to 6 colors means like text in like, let's say, gray. If you want to highlight text, it would be black. Visuals, highlighting things would be green, negatives would be red, kind of things. Like stick around to 6 colors when you're around 6 colors when you are developing a dashboard. So, and always try to follow the normal color grading patterns, like positives green, negatives red, that kind of things. And one thing is, like, when it comes to coloring, one important thing I want to mention is like there are color palettes called color. So there are colorblind people. So sometimes if you show positives and negatives in red or green, sometimes for a colorblind person, both the things would be the same. So there are color palettes that suits color. They are called colorblind palettes or something. You can focus on those things also when creating a visualization. Do not select wrong charts. Always try to stick to correct chart type. Identify your data types, identify your data volume, and identify your platform that you are using. And according to those things, try to select your chart. Do not do cherry picking. Cherry picking is like, do not pick data from here and there so you can like deliver a favorable story. And do not omit data. Like, do not remove unnecessary, not unnecessary, like unfavorable parts. Do not remove from your visual story. That would tell a fully different story than the actual story. So do not do cherry picking. And unlabeled graphs, always try to label your graphs depending on how you label. Maybe on the title you can introduce the X or Y axis, or else in the chart itself you can introduce the X and Y axis. And do not overload your audience with too much information. Keep it simple. Do not overload with information. Always try not to compare more than 2 variables at once. Normally, like I think as humans, we cannot like compare 4 variables. Like, we cannot plot 4 variables at once, and make it 2, maximum 3. When you're creating a chart, do not go beyond that. So I would prefer comparing 2 variables, because it's like very straightforward. You can select, okay, time, year versus sales, year versus tourist visits. So that's very straightforward. Sometimes you have to use 3 variables, maybe like on bubble charts, depending on the use case. But if you can like segregate that large story into 2 different stories, then you can simplify your story. So do not overload your audience with information. That's one thing. So these are the 10 bad visualization practices that I wanted to discuss with you today. And I think you got a good idea on those 10 charts, and please avoid doing those 10 bad visualization practices. So the princess here is like your job, and the fairy dragon is like your manager, and Pinocchio is you. So watch out for those long nose movements and never lose your princess. So like someone asked me a question with in my experience, whether I have come across things that I have to manipulate visualizations. So it's like job is like your princess, and trying to impress others, don't lose your princess. That's, I think, the best takeaway that you can get from this story. Okay, thank you. Hope you enjoyed and learned something. And if you want to know anything in the data visualization domain within the industry, you can contact me on LinkedIn. I would be very much glad to support you on anything that I know of. This is how I created my storyline for this presentation. Just wanted to go through it with you, like how I maintain the story flow. So I first looked at who will be my audience, and that should be context. So my audience is like you people, masters. You are doing a masters, and Lakshita said that you are from different backgrounds, so there are technical and non-technical people. And I wanted to tell you about data storytelling and misleading visualization. That was my task, and I focused my presentation towards that audience and context. So I didn't involve too many technical things in the presentation. I wanted to keep it simple and like a story. So all these storylines, I'm not sure whether you click that. All the storylines went with black color slides, and what I wanted to teach to you went on white color slides. So that's how the story was planned. I will start the story and go to the conversation. Then I'll tell about data storytelling, phases of a story. Then back to Pinocchio's story, the story of Princess and Dragon. Then I will go through task by task with the audience, describing each task, Pinocchio's chart, and how to correct, and the related theory. Then I will move to the end of Pinocchio's story, summarize my learning, summarize what I want to give to you, the learnings from this presentation, the bad data visualization practices. And finally, I map the characters into real world scenarios. So Princess is like your job, Dragon is your manager, and Pinocchio is you. So I think you can relate to this story when you are in industry. So it comes to the end of the presentation. I think you enjoyed it. We have some more time. I'm free if you want to ask any questions also. Thank you everyone for participating in like a Monday evening.
Yeah. Thank you, Kanishka. So anyone, do you guys have anything to ask from Kanishka? Either everyone understood all the stuff or none at all? Right, okay. Then thanks, Kanishka, for spending 1.5 hours with us and explaining about your journey in visual storytelling and going through this amazing journey with Pinocchio, rescuing the princess. And I hope all of you got an understanding about what deceptive visualizations that are there and how not to fall into those traps, and then design a better visual. So thank you so much, and that concludes today's session.
Thank you, everyone.
Thank you, Kanishka.
Thanks a lot.
Thank you, everyone.